you will have a propanol, which means you have 3 carbons. So we have 3 carbons, and on the second carbon I have an OH, and so we can actually draw out all of our hydrogens here to help us solve this question. And so the first part is an oxidation. So I'm looking at an oxidation. That means that I'm adding oxygen, or that means I am getting rid of oxygen. Am I adding hydrogen or getting rid of hydrogen? So you should think oxidation means more bonds to O, less bonds to H. And so I'm looking for more bonds to O, less bonds to H. And so we're going to take this, and we're going to cut. We're going to make more bonds to O here, and we're going to remove this H here. And so we're going to cut this H, and we're going to make a double bond here. Because remember, carbon can only have 4 bonds around it, so we got to cut that H. And we'll cut this H here because the oxygen is going to be overloaded with electrons if it does that. So I'm going to make, with an oxidation, I'm going to make CCC with a double bond O. And so this is what but a ketone? This is propanone. And if I'm doing a dehydration, we should be thinking, oh, I'm so dehydrated. It means I haven't had enough water. So we need to remove a water. And water is an H and an OH. So we need to remove an H and an OH. So let me back up. Oh, I can't really back up from that, huh? Let me reset my 2-propanol here. And then let's do the dehydration. We'll do it in a different color. So my dehydration, I'm going to be getting rid of a water. And so for here, you're going to decide which H is going to go. Because it's this 2-propanol, it's even on both sides, so it doesn't really matter. You also see our product is going to be a double bond on carbon 1 no matter what. So I'm going to cut it off, getting rid of an H and an OH. This is going to become water. And so we're going to make, and now we cut this off, then my carbons won't have enough electrons around them, so this is going to turn into a double bond, and so we're going to wind up with this, which is an alkene. We're going to have 2 H's hanging off here, 1 H hanging up here, and then we have our 3 H's down here. Again, it doesn't matter of which side you do it, you're still going to wind up with a double bond on carbon 1 because we can rotate that around and we'll name it that way. You're also going to make water if you want it to be super thorough in your answer. Alright, so I didn't put what goes over the arrow, so sorry about that. The textbook and the homework is gonna want you to do that. So you're writing out the full. It said give the primary product, but writing out the full reaction. You will have your little oxidation here, and how does dehydration happen? You have to use an acid, and you have to heat it up. It's kind of the opposite of making the alcohol, where you can do the other reactions in acid, but you don't have to heat them. So, with a Tollens reagent, so remember a Tollens reagent is Ag+, and that Ag+ is going to go to Ag0, so it is getting reduced. So this is really an oxidation. So all of these are just oxidizing, right? And so if this is a reduction, then your compound gets oxidized. So it's just getting oxidized with a silver hanging around. So your compound's getting oxidized. So what we're thinking of is any way that we can oxidize things. And so oxidizing, I want the structure and the name of them. And so oxidizing each of these 3 things. So pause and go through and try to find what happens when you oxidize them. So here are your solutions. So you can just write Tollens over the arrow. So you've got butanal here, which is 1, 2, 3, 4 butane with an aldehyde, so butanal. And if you oxidize an aldehyde, the only place we can add an O is right in here, and so we get butanoic acid. We'll talk about carboxylic acids in the next chapter. I'm sorry, chapter 14. If you have acetaldehyde or ethanal, ethanal, acetaldehyde, you do a Tollens, and you're going to get acetic acid, right? The only place we can add an O is right here, so we get acetic acid or ethanoic acid. If you get ethyl methyl ketone in Tollens, there's no reaction, remember, because Tollens is really great at identifying aldehydes not ketones. So if you get a reaction with toluenes, you get that silver mirror, then you have an aldehyde, a simple aldehyde on your hand, versus ethyl methyl ketone is a ketone, and they're not oxidized by toluenes reagents. And so that's one way of separating what you have, or one way of telling what you have in your flask. I would highly recommend, again, to maybe print these out, have these ready to go as you study, to help you know that primary alcohols oxidize to aldehydes, which then oxidize to carboxylic acids. That will help you with the toluenes reagent too. So you can stick a little word in here like, oh, that's for toluenes as well. And we're not oxidizing ketones, right? So toluenes doesn't work with ketones. And so this is going to be really helpful as you continue your studies.